this assessment acknowledges that based on the atomic mass units, there are 75 possible constitutional isomers that this could represent. And yet, fragmentation patterns are going to tell us that it's exclusively one constitutional isomer. Now, this particular spectrum has been chosen because it makes it easy to solve, but allows us to kind of logically piece through what the mass spectrum is showing. And so here's the two things that we have to keep in mind. Any peak that's shown represents a fragment that is there. So this piece of the molecule that has fragmented has a mass of 29 atomic mass units. We also know that this is going to only have carbon and hydrogen. Carbon has 12 atomic mass units. Hydrogen has 1 atomic mass unit. So this 29 is going to be composed of some number of carbons and hydrogens. Well, to give 29, that's going to probably correspond to an ethyl group, CH3, CH2. That would give us the 29. 12 plus 12 is 24, plus 5 is 29. So knowing that each fragment, each peak in the spectrum tells us what fragment must have been there, there's another piece of information we can get, and that is that the difference between two fragments is going to be an atomic mass or a fragment, a piece that was lost. So when going from 29 to 43, that's a difference of 14 atomic mass units. Well, how can you make 14 atomic mass units using carbon, which is 12, and hydrogen, which is 1? It could be a CH2. So to go, and that kind of wrote over that relative intensity, but there's a CH2 written there. To go from 29 to 43 implies that there's another CH2. We can put that there. From 43 to 57 is another 14, so another CH2. From 57 to 71 is another 14, or another CH2. Continuing that on, 71 to 85 is another 14, or another CH2. From 85 to 99, another 14, or another CH2. From 99 to 113, another 14, another CH2. And now to get from 113 to 412, or from 113 to 142, that's another difference of 29, which we started was our ethyl group. So we're going to have another CH2, CH3. Just barely kept it on the screen. This is the structure, the constitutional isomer that is represented by the spectrum shown.